So good afternoon everyone. Today I am going to discuss about the computer network subject unit 4. In previous class we have discussed the introduction topic network layer. Now I am going to continue that topic. So coming to the conjunction control. So our topic is conjunction control. So today I am going to discuss this topic. So what is meant by conjunction? So too many packets are present in the subnet and the traffic increases, then the network performance degrades and no packets are delivered to the destination. The situation is called as conjunction. Okay, so traffic is nothing whenever we are transmitting the data packets from one node to another node, we are having one subnet middle of that. So we are sometimes overflow of data, traffic will be increases, the network performance will be degrades, and no packets are delivered in the destination. So that situation is called the conjunction. Okay, so it's called conjunction. So when the number of packets host sent into the network is well within its carrying capacity, the number delivered is proportional to the number sent. If twice as many are sent, twice as many are delivered. As the offered load approaches, the carrying capacity bursts of traffic occupationally fill up the buffers inside the routers and some packets are lost. So the network is now congested as the given diagram. So below diagram, so this is the below diagram. So it is the good packets per second, good putter. Okay, this is the offer load packets per second. So this is the capacity of the network. So our graph is moving upwards. It is a desirable response. So if the curve is ideal, it will be a desirable response. If the curve is something onset of conjunction, so the conjunction collapses. Okay, so this is the graph of the conjunction control. So what is the this is called conjunction. So what is meant by conjunction control? It is a process of maintaining the number of packets in a network at certain level. It makes sure that subnet is able to carry the offered traffic. Okay, so approaches to conjunction control. So the presence of conjunction means this is the conjunction control. Now only I said that it is a process so of maintaining the number of packets at certain level of level in the network. It makes sure that subnet is able to carry the offered traffic. Okay, this is called the conjunction control. So next in the conjunction control algorithms we having some network provisioning, traffic aware routing, admission control, traffic throttling, load scheduling. Okay, next coming to approaches to conjunction control. So what is mean by approaches to conjunction control? The presence of conjunction means that the load is temporarily greater than the resources in the part of the network can handle. Two solutions come to mind: increasing the resource or decreasing the load. Increases the resource or decreases the load and can be classified into some following. So this is the approaches of the conjunction control. So preventative, reactive. So here slower, here faster. So slower at network provisioning, traffic aware routing, admission control, traffic throttling, and load scheduling. So these are the approaches now we are going to discuss. So coming to first one, network provisioning. What is mean by network provisioning? The most basic way to avoid the conjunction is to build a network and is well matched to the traffic that it carries. So if there is a low bandwidth link on the path along with most traffic is directed, conjunction is likely. Sometimes resources can be added dynamically when there is a serious conjunction. For example, turning on space routers or enabling lines that are normally used only as often links and routers that are regularly heavily utilized or upgraded at the earliest opportunity. So this is called the provisioning. Okay, next coming to traffic aware routing. So what is mean by traffic aware routing? In order to make use of most of the existing network capacity, routers can be tailored to traffic patterns that change during the day as network users awake and sleep in different time zones. For example, the routers may be changed to shift the traffic away from heavily used paths by changing the shortest path weights. So this is called traffic aware routing. Splitting traffic across multiple paths is also helpful. So the goal is taking load into the account when computing routes is to shift traffic away from hotspots that will be the first place in the network to experience congestion. The most direct way to do this is to set the link weight to be a function of the fixed link bandwidth and propagation delay plus the variable measured load or average queuing delay. So least weight path will then favor paths that are more lightly loaded, all else being equal. For example, consider the network which is divided into two parts, east and west, connected by two links, east and west. So see, this is the diagram, example diagram. In this network which is divided into two parts, east and west and east, connected by two links, CF and EI. Suppose that most of the traffic between east and west is using link CF, and as result this link is heavily loaded with long delays. So including queuing delay in the weight used for the shortest path calculation will make EI more attractive. After new routing table have been installed, most of the east-west traffic will now go over EI loading this link. Okay, so this is called the traffic aware routing. Next one, third one is the third one, admission control. So one technique is that widely used in virtual circuit networks to keep congestion at bay is admission control. So the idea is simple: do not set up a new virtual circuit unless the network can carry the added traffic without beginning congested. So we attempt to set up a virtual circuit may fail. So if the virtual circuit network, new connections can be refused if they would cause the network to become congested. This is called the admission control. So by analogy, in the telephone system, when a switch gets overloaded, it practices admission control by not given dial tones. Okay, dial tones. This is called the admission control. So admission control. In this admission control, I having the diagram. So this is so admission control can also be combined with the traffic aware routing by considering routers around the traffic hotspots as the part of the setup procedure. For example, consider the network in which two routers are congested. Okay, so in this we are having a congestion network. A is a congestion network and B is the portion of the network that is not congested. A virtual circuit from A to B is also shown here. So suppose that a host the host is attached to a router. Suppose a host is attached to a router A wants to set up a connection to a host attached to router B. Normally this connection would pass through one of the congested routers. To avoid this situation, we can redraw the network and omitting the congested routers and all of their lines. The dashed line, so whatever the dashed line we are seeing in this diagram, so that is possible route for the virtual circuit that avoids the congestion routers. So this is called the control congestion. Okay, next fourth one is traffic throttling. When a congestion is imminent, it must tell the senders to throttle back their transitions and slow down. This feedback is business as usual rather than an exceptional situations. The term congestion avoidance is sometimes used to construct this operating point with the one in which the network has become congested. So let us now look at some approaches to throttling traffic that can be used in both datagram network and virtual circuit network. So each approach must solve two problems. First, routers must determine when conjunction is approaching. Ideally, before it has arrived. To do so, each router can continuously monitor the resource it is using. So there are possibilities or the utilizations of the output links is buffering of queued packets inside the router and the number of packets that are lost due to insufficient buffering. The second problem is that routers must deliver timely feedback to the senders that are causing the conjunction. Different screen uses in different feedback mechanism. So this is called traffic throttling. Okay, next one, choke packets. So the most direct way to notify a sender of conjunction is to tell is directly. So if in this approach the router selects a congested packet and sends a choke packet back to the source host, giving it the destination found in the packet. The original packet may be tagged so that it will not generate many more choke packets further along the path and then forwarded in the usual way. To avoid increasing load on the networking a time congestion, the route may only send choke packets at the low rate. Okay, so this is the choke packets and this is the diagram of the choke packets. Here I having the A, B, C, D, E, F. Okay, so what we are doing when I am using the choke. So what is the use of choke? Okay, choke. The direct way to identify the sender of conjunction is to tell it directly. In the approach, router selects a conjunction packet and sends the choke packets back to the source host. Okay, so here having the choke and again backwards it will be occurred. So here I am sending D to F. After F to E to A. Okay, again E to A. Okay, so how is getting ma? So this is the choker package. So A to E, E to F, F to D. Okay, this like our data is moving. Okay, so here also same. Choke is moving to here. Okay, this like reduced flow and this is the flow is still all maximum rate. So flow is reduced here. So okay, so this is the choke pockets. Okay, packets. Next coming to explicit conjunction notification. So instead of conjunction additional packets to warn of conjunction, a router can tag any packet is forwarded to signal that is experiencing conjunction. When the network delivers the packet, the destination can note that there is a conjunction and inform the sender. When it sends a reply packet, the sender can then trollate its transmission as before. This design is called the explicit conjunction notification and is used in the internet in this diagram. So I having the host here and at the end I have the other host. Middle of that we having the package, conjunction router, market packets and these are the routers available. Okay, so whatever the packets we are sending, that is arrived at the conjunction signal. Okay, conjunction signal. So this is the explicit conjunction notification. Next, hope by hope back pressure. Another way to reducing conjunction is that necessary action is taken at each hope to hope reduce the traffic towards the congested destination. After receiving the choke packets, using this method, conjunction is reduced faster. So this is called the hope by hope back pressure. So here also having the heavy flow. When compared to here, we are having heavy flow and the transmission will be occurred from A to E, E to F, F to D. So here I have a heavy flow. Next it comes to the backwards, choke, again choke. Okay, so this so this is called the hope by hope back pressure. So next we got load shading. Load shading is a fancy way of saying that when routers are being inducted by packets that they cannot handle, they must throw them away. So the term comes from the the term comes from the world of electrical powers generation when it refers to the practice utilization intentionally blacking out certain areas to save the entire grid and collapsing on hot summer days when the demand for electricity greatly exceeds the supply. The key question for the router drawing in packets is which packets to drop. So the preferred choice may depend on the type of applications that uses the network. For the file transfer, an old packet is worth more than a new one. This is because dropping packets 6 and keeping packets 7 through 10. For example, we only force the reverse receiver to do more work to buffer data that it cannot yet use. This is called load scheduling. Okay. Next, coming to this, in the load scheduling, we having some real-time media. New packet is worth more than old one. This is because of packets become useless if they are delayed and miss the time at which they must be played out of the user. Another useful way of discarding the packet is assigning the properties to each packet. Packet with a low priority will be discarded. First and packets with a very high priority will never be discarded. Randomly early detection (RED) is used in the loading schedule. Next one is quality of service. So what is mean by quality of service? Each solution must be addressed to ensure quality of service when application needs from the network. How to regulate the traffic? Regulator how to reserve the resource at the routers to guarantee performance, whether the network can safely accept more traffic. Okay, more traffic. This is called quality of service. And loss, and assuming the decent routing schemes, we deliver packets with low latency. So issues of quality of service when applications need from the network, how to regulate the traffic that enters the network, how to reserve resources, how to reverse resources at routers to the routing performance. Okay, so whether the network can safely accept more traffic. So okay, in this application requirements, first one is the application requirements. So a stream of packet is from all source to destination is called a flow. A flow might be all the packets of the conjunction in the conjunction oriented network, or all the packets is sent from one process to another process in a connectionless network. So the needs of each flow can be characterized by 4 primary parameters: bandwidth, delay, jitter and loss. Together this determines the application requirement. Quality of service. So the flow requires several common applications, and they are stringency of their network requirements are listed. So these applications differ in their bandwidth needs. So here having applications: email, file sharing, web access, remote, audio, video demands, telephony, video conferencing, everything will be have bandwidth, delay, jitter, loss. So delay means low performance. Okay, slowly opening. Delay means it will be, we have to wait some time, and jitter means it is complete error, and loss means which our data is lost in due to collisions or anything. So these are the application requirements of the congestion control. So next, so categories of quality of service and examples. So in this category, categories of quality of service and examples. So okay, constant bit rate telephony, so real time variable bit rate, compressed video conferencing, non real time variable at a rate, watching a movie on demand, available bit rate, final transfer. So these are the different categories in quality of service and approach. Okay. Next, traffic shaping. So what is a traffic shaping is a mechanism to control the amount and the rate of the traffic sent to the network. When a virtual circuit is the user and the subnet agree on certain traffic shapes for most circuit, traffic shaping reduces the computing congestion, improves the quality of service. Two types of alignments are used for traffic delay. One is leaky bucket algorithm. So leaky bucket based bucket, it is small with a small idea in the bottom, small in the bottom is used to store that water on his bucket. If full any additional water entering it spoils over the sails over the sides and it lost. Okay, the same idea is applied to the same idea is applied to the packets which has host is connected by the network by an interface containing the leaky bucket, that is finite internal queue. If a packet arrives at the queue when it is full, the packet is dedicated. So the packet is allowed to put one present per clock to the network. Okay, so this is called the leaky bucket algorithm. Okay, so next coming to the packet scheduling. So what is mean by packet scheduling? So packet scheduling is nothing but packet to provide a performance guarantee, we must reserve sufficient resource along the route that the packets take through the network. So competing flows are called packet scheduling algorithm. Three different kinds of resources can potentially be reserved for different flows, that is bandwidth, buffer space, cycles. So the first one, bandwidth is most the first one bandwidth is the first one bandwidth is most obvious. If the flow requests 1 Mbps and the outgoing line has a capacity of 2 Mbps, trying to direct 3 flows through that the line is not going to work. So thus reserving at bandwidth means not over subscribing any output line. So second resource that is often in short supply is buffer space. When a packet arrives its buffer inside the router will inside the router until it can be transmitted on the chosen outgoing line. Okay, the purpose of this buffer is to observe small bursts of traffic as the flows contended with each other. If no buffer services, some buffers might be reserved for a specific flow, so that flow does not have to complete the buffer with other flows. Okay, up to some maximum value, there will be always be a buffer. So finally, CPU cycles may also be sparse measure. It takes router CPU time to process a packet. So a router can process only a certain number of packets per second. Packet schedule algorithm allocate bandwidth and the other router resources by determining which of the buffered packets to send on the output line next. We already described the most straightforward scheduler when explaining how routers work. Each router buffers packets in a queue for each output line until they can be sent, and they are sent in the same order that they arrived. The algorithm is called as first in first out, so or equally FS, first come first serve. Okay, this is called the packet scheduling. Next, bandwidth admission control. So admission control, quality of service guarantees are admission through the process of admission control. The user offers a flow with an complying quality of service requirements to the network. The network describes whether the network then decides whether the accept or reject a flow based on its capacity and the commitment it has made to other flows. If it accepts, the network reverts the capacity in advance at routers to guarantee the quality of service when traffic is sent to the new flow. So this reservation must be made at all of the routers along the route that the packets take through the network. Many routing algorithms find a single best path between each source and each destination and send all the traffic over the best path. This may cause some flows to be rejected if there is not enough to share the capacity along the best path. Quality of service guarantees for few flows may still be accompanied by choosing a different router for the flow that has excess capacity. So this is called a quality of service routing. Chen and give an overview of this technique. It also possible to split the traffic for each destination over multiple paths to more easy find the express capacity. A simple method is router to choose a equal cost path and divide the traffic equally and it proportions of the capacity of the outgoing links. So this is called the admission control. So next admission control. Next one is next is the internet working. In the next class I will discuss. Thank you everyone.